Hey Grandma, so we're still in our immunology section of the course, and so I'll still be able to answer some of your questions. The first one was, what is cell-mediated immunity? And well, remember from before, you have two types of immunity, which was innate immunity and acquired immunity. Cell-mediated immunity is one of the two types of acquired immunity, the other being humoral. In cell-mediated immunity, basically what it is, it's cells communicating with each other to create an immune response. So you have T cells, right, and antigen-presenting cells, such as dendritic cells, macrophages. These types of cells present information to T cells, which then promote an immune response. And this usually happens within lymph nodes, which is your second question. What happens in lymph nodes? Basically, let me explain what a lymph node is. First of all, a lymph node is in your lymph system, and a lymph system is kind of similar to your cardiovascular system, in which you have fluid flowing through it. The only difference is that in cardiovascular system you have blood flowing through the vessels, and in lymph vessels you have lymph, or filtrate, basically, from blood, like the filtrate. So just like your blood vessels travel all across your body, this is a picture of a neck here, and these would be like little lymph nodes. And a lymph node is basically like an intersection in this highway, and this is where cell mediation happens. So what you have then is cells come along, immune cells come along, dendritic cells, and a dendritic cell might find some kind of pathogen in your tonsils or something over here, right? And then it gets into the lymph node, and basically it starts presenting the information to T cells, which is what cell mediation is. And that's kind of where the action happens. Once those T cells are activated, then other T cells are activated, such as killer T cells, and what happens then is you basically have the onset of combating that pathogen. So you're going to have bacteria in here. T cells are combating, and other dendritic cells and macrophages are kind of eating up those bacteria. A lot of stuff's going on there. What might happen is you might start to have some inflammation of that lymph node, which then you can see, like when some people have strep throat, they basically have some swelling to the area of their neck. So third question was, what do cytokines do? What cytokines do cells secrete, and what do they do? So there's different types of T cells, like I said. You have CD4 cells, CD8 cells. You have different types of T helper cells, including type 0, type 1, type 2, type 17. You have memory T cells. You also have regulatory T cells. But here's another diagram that I have here. And so you have your antigen presenting cell, which usually connects with a T helper cell, in this case type 0. And what happens is that once these T helper cells are activated, they either create interleukin 2, such as for type 0, which activates more type 0 T helper cells. If we move along here, they also activate, this interleukin 2 activates T helper 1 cells, along with other cytokines. These type 1 T helper cell then creates more interleukin 2 as well, but it also produces the cytokine interferon gamma, which then activates macrophages to go ahead and phagocytize any bacteria in the area that they're in. Also, type 0 also produces interleukin 4, and which helps promote and activate type 2 T helper cells, which then also produces interleukin 2. Interleukin 4, and also interleukin 5. But interleukin 4 is important because it goes ahead and promotes the expression of immunoglobulin E within B cells. Once this happens, B cells then form into plasma cells, and they then create antibodies. Basically, here I just drew one there, but they create so many more. Another regulatory cytokine produced by T cells would be like transforming growth factor, TGF beta 1, and this is produced by regulatory T cells. Once this cytokine is produced, then this promotes the expression of P3, and it then binds to DNA, which promotes the expression of other proteins, which then activate more regulatory T cells. And T regulatory T cells are pretty much important because they kind of suppress the activity of T cells. You don't want to have a major blowout of T cells going crazy, because then you can have a pretty dramatic response. But so it kind of suppresses the immune response just to enough for it to make an impact. If you don't have TGF beta 1, it can create an autoimmune response or autoimmune diseases. But that's all the time I have right now. So great talking to you again. If you have any other questions, please let me know, and I'll try to get back to you. All right? Talk to you later.